Okay. All right. So on Tuesday we talked more about JavaScript and event handling. I want to begin today by finishing up a little bit more on the example that we did then. So the example that we did on Wednesday was this rects example. We've got this rectangle. We have a button down here, or a text form down here where I can add some new rects to the page. Let's see, I'll add like 50 or something. Doesn't seem like it's working. We have rect.js. Let's open up our code and do some debugging. Rect.js. Oh, you know, I might have messed this up. I think I might have published a non-working version. Okay. Add event listener, submit, add rects, add rects. Okay, that's not getting run. Add form, where's the form? That's the name of the form, right? Yeah, add form. Add event listener. Submit, add rects. Okay, we're just going to change this to on submit equals add rects for now. Okay, what's the problem here? Add rects. Is there a problem in add rects? You guys get to see me debug real time. This is sort of how you go about debugging in, there we go. Okay, so that worked. No, it didn't. Add rects is the function that we want to. So the thing about JavaScript is that it often doesn't give you errors precisely where something, oh, here we go. Okay, that's the problem. I misspelled psychedelic the other day and I corrected it. Okay, here we go. We'll uncomment this stuff. And now if we do add rects, there we go. Okay. Sorry about that. Okay, so we have this button here where we can click to add a certain number of rects to the page. When we hit color, it will go psychedelic for a moment, and for 3 seconds, and then it will stop. And in order to do that, we used a timer. When we have, let's see, go psychedelic, we set an interval timer that runs every 20 milliseconds. Every 20 milliseconds, it's going to recolor all the rectangles on the page. So it's going to call color rects every 20 milliseconds. Then after we set that up, then we also set a timeout so that after this sort of like an alarm thing, after 3,000 milliseconds, which is 3 seconds, then we're going to call this function, which is going to clear this timer, which has the effect of turning this off, stopping this. Okay, and we also have, like, if we click on any of these, they get removed. What I want to do is I want to add another feature. I want to make it so that if I click and drag any one of these, I drag it around the screen. So I want to do drag and drop. And in order to do that, let's do, so we're going to have to be using a couple of different event handlers. And the approach to this, you sort of have to break it up into 3 different phases. First is the mouse down phase. When I put my mouse down on something, I want to start like sort of keeping track of where it is on screen and moving it around. So there's no sort of like way that I can just, say, when the mouse goes down, move it around with the mouse. You have to actually, as we update, as we move the mouse on screen, if we go, 5 pixels across and 2 pixels down, we have to move the box 5 pixels across and 2 pixels down. And in order to do that, we have to make use of the mouse move event. And then once we release the mouse, then we have to stop moving the box. So we have to stop keeping track of our coordinates. Okay, let's go back and take a look at the slides from Wednesday. We will take a look at the events, some of the events that we can use. So let's look at the mouse events and the coordinates. So we're going to make use of some of these coordinates here. We're going to, in order to move the box, we're going to have to place it within its containing element. So I think what we're going to have to do is, let's see, in order to get its position, I think we're going to have to use this non-standard offset x and offset y, which are its position within its containing element. So let's do that. And we're going to make use of mouse down. When we mouse down, we're going to start like moving the box. When we mouse up, we're going to stop moving the box, and we're going to move the box anytime there's a mouse move event fired. The thing about mouse move is that it's not, you'd sort of expect that it gets fired like, every time you move any tiny little increment on screen. But actually JavaScript and the browser only fires it every like 20 milliseconds or so. It only keeps track of, you can actually jump pretty far before a single mouse move event occurs. So I could, if I move my mouse really quickly, across the screen like this, there might be a mouse, the first mouse move event might be fired like by the time I reach here or something. So, it doesn't fire a mouse move like for every pixel that I go through. So let's do this. We're going to have to each rect, we're going to have to add some event handlers, and we're going to do it the way that we did it on Wednesday. So we create the rectangles. Oh, I forgot to update this so that it uses the add event listener. So let's do that. Add event listener click, comma, remove. Let's do another one. Rect.add event listener mouse down, start moving, start moving. And then let's see, we'll do mouse move maybe. We'll just call this start and then move, and then mouse up, stop. Let's do that. So those are going to be the 3 things that we're going to do. We'll create functions for those. Function start, function move, function stop. Okay, when we start, okay, let's focus on move. When we move, mouse move events are going to be fired all the time. Whenever I'm within these elements, so whenever my mouse is over any of these elements, so there are mouse move events being fired constantly while I'm moving my mouse over this. But we're not going to actually be doing anything unless the mouse button is pressed. So when the mouse button is pressed, then we're going to actually respond to the mouse move events. Okay, so inside of this function, we need to see if the mouse button is pressed. How would we go about doing that? Yeah. So make a Boolean value that's accessible in all these methods. So I can check, if, I'm dragging or something, then I want to actually update coordinates of the box, maybe. And then we would set this variable here when we start, so we can say dragging equals true, and then when we mouse up, we say dragging equals false. Excellent. So in order to get access to this, we have to create a global variable up here. Var dragging equals false. Oh, another thing I forgot up here was use strict. That's an important thing to use. Yeah.
So it's outside that function. It's not inside the function. And
Dragging.
So for use strict, doesn't it have to be outside of it?
Use strict will apply to whatever scope it's inside of. So this is inside of a function scope, and it will so it'll apply to everything inside of this iffy. Remember, we call this an iffy. Okay, so let's see. So we have this global pseudo global variable out here. We're setting it to true when we start and stop when we false when we stop. Okay, so if we're dragging, then we want to update the coordinates of the box. So we need to find, so when this mouse move event occurs, say, our mouse has moved from like here to like here. Okay, so we've gone over like 5 and down 1 or something like that. Okay, we need to find the new coordinates here, and we need to update the location of this rect to be right here instead of right there. Okay. So in order to do that, we need to know where it was previously and where it is now. So how do we find out where it is now? Why don't we just, we'll use something called, we haven't used this in lecture yet, but this is a really, really useful debugging tool. We'll use something called console.log. Console.log outputs a little message to the JavaScript console here. So this area here, oops, bump that size up there, excellent. So it'll output a message here, and it's really useful for debugging purposes without completely taking over the UI with an alert. So if we do console.log, how do we get the current coordinates of this maybe inside of its containing element? So we looked at the ways of getting the current coordinates here. So in order to get the current coordinates inside its containing element, we're going to need to use offset y and offset x. So let's just alert those. We'll start by alerting those. So how do we get offset y and offset x? Do we just say offset y, offset x? Actually, we should do xy. We do that. How do we get access to offset y and offset x? We need, no, we don't actually need a DOM object. What are we missing? It's on this slide. Yeah, we have to have this event object. This event object is something that automatically gets passed to any event handler, but we haven't captured here. So if we capture it, then we can make use of it. And offset x and offset y are properties of this event object. So we're going to do those. We're going to alert offset y and offset x. We'll open up the console here and maybe color. All right. Now when I mouse over this, oops, there we go. Okay, those are undefined. So it looks like we can't use offset y and offset x. Let's just look at like client y, client x, client y. Okay, so as I'm moving around inside of this, every time I move the mouse, I get a different coordinate of where this is. That's within the entire page. So, how do we position the element? Yeah. So offset X and offset Y are not standard. So it looks like Firefox doesn't support them. Some browsers do support that, but this browser does not. Actually, the other thing that we can do, let's see. So these these rects are all within rectangle area, and they're all. How are we positioning them in rectangle area? How are we giving them like coordinates inside a rectangle area? Yeah, so they're absolutely positioned. And where are we? Let's see. Position absolute. And then we're giving it a random location. Giving it a random location involves setting its left and top properties. So if we get the existing left and top properties, we can change them. So we can see where the current coordinates are and then change it to the new coordinates. So why don't we do that? And we do that. Let's see. So we're going to have to use get computed style, right? Get computed style gets whatever styles are applied to it. Although actually we don't need to use that because we have explicitly set .style .left and .style .top for each one of these. Okay, so let's we'll just say var left equals. So we're moving on a particular object, so we can make use of this .style .left. We're gonna have to parse that as an int. Top, style.top. So these are the two existing coordinates. We also need to make use of where the mouse button is now. So, how are we going to move from the previous location to the current location? Calculate the distance between the current position and the new, so like the current position of the box and the new position where we want it. Okay, but we're gonna have to think about this for a sec. So client X and client Y, those coordinates are within the browser window. So all the way up to the top of the screen and to the left of the screen. And then we also have let's see. We also have page X and page Y, which are the distance from the click to the top of the page and the click to the left side of the page. So the top of the page might be scrolled partly off screen. Client Y would only go up to the top of the screen. Page Y would go all the way up top. Okay. So how are we going to go about figuring out this thing's position inside of its containing element?
Get the screen X and screen Y of the box that it's in,
Mm-hmm.
mark the box, and then subtract the screen X and screen Y for your specific rectangle from that box.
Mm-hmm. So let's console.log when we click on something, when we mouse down, let's console.log event. So like, let's see. So this is the box that we clicked on. If we go to its parent node is the node that contains it, the DOM object that contains it. Why don't we say like, let's just alert that. Oops. So we're going to alert that. So it's a div with the ID of rectangle area, and then we'll inspect that's properties. Let's go to its DOM properties and see if there are any DOM properties that we can make use of. Client left, client top, client width, client left, client top, client width. Offset left, offset parent, offset top, offset width. Ooh, those look like the properties that we're looking for, right? Offset top, offset left. Those look like the properties that we're looking for. It's 8 pixels from the left, and it's 8 pixels from the top of the screen.
Oh, so you don't even need to ask this parent mode. You can just do that for the rectangles, offset top and offset.
Yeah, I guess, let's see, offset left. Let's see, this dot offset left and this dot offset top. That might be. Is that, let's see, this dot offset left, this dot offset top. Let's do this. I'm going to change that to half a second. Okay, color. Okay, so rectangle. Let's look at this rectangle. Let's look for its offset left and offset top. Okay, its offset parent is null. Okay, that must be because I removed it. Okay, so offset left, offset top. Those are the current coordinates. Let's do dot offset left, this dot offset top. Okay, so those are its offset, so those are its existing coordinates. And we will need to make use of those. We'll need to calculate the difference between the existing coordinates and the new coordinates. So what we can do is we can say, so these are the current left and current top. What we want to do is make them into, actually we just want to say this dot style dot left equals this dot, no. Okay, we still need to look at the location of the mouse cursor. So we need to figure out. So let's see. Will be this dot offset left plus this dot parent dot offset left. Okay. So that's the current location of the cursor. No, this is the current location on screen of this element. Okay. I always forget how difficult this this example is, and I kind of forgot how to do it. So, so element left, left top. Okay, then we can make use of client Y, client X. Actually, no, we're going to do page X, page Y. Okay, so let's do console.log element left page X element top page Y. node. Okay, so 133 to 161, 522 to 553. So those are the coordinates I'm changing. So the x coordinates is going from 133 to 161, and the top is going from 522 to 553. Actually, even that is not right, because what we've calculated is the top left of this, and the mouse cursor is inside of that. Okay, you know what, we're spending too much time on this, so I'm going to move on. And maybe we'll finish that up on Monday. Okay, so we need to get to new material for today. Okay. So, what we're going to be talking about today is, I think it can be safely called the first true revolution that existed on the web. At the time that this came about, the web had only been mainstream for about 10 years or so. It only existed for 14, 15 years, and it had only been mainstream for about 10. And it had gotten to the point where it was starting to be like, it was really the next big thing. It was starting to be pretty pervasive, but it wasn't quite to the point where it was an entrenched part of everyday life as it is now. And I feel like this is what kind of pushed it over the edge. This is what made the web into the super powerful, incredibly useful tool that we have today. It was a combination of a lot of things. People started to use the DOM a lot more. People started to use JavaScript a lot more to make more interactive pages. But this is really, I think, the crucial component that made the web into what it is today. So this is a really important application of JavaScript and a really powerful tool. So up until now, what we've been doing is what's called synchronous web communication. This involves basically the traditional page fetch cycle. You click a link, or you type in a URL in your browser requests the page that you're going to from the server. The server has some amount of lag or delay in responding to you, maybe 20 milliseconds, 30 milliseconds, and it sends the data to you. The browser spends some time parsing the HTML code, making additional requests like to the CSS file, to the JavaScript files, to image files, things like that. It parses everything, renders everything, and then finally displays the entire page's contents on screen. So that's the page fetch cycle, and in between clicks, in between page fetches, we have to wait. We wait a little while the request is made to the server and the browser re-renders the new page. Web applications have evolved to the point where they use a sort of internal navigational structure and internal sort of JavaScript-based user interfaces, which allow you to show different panes and hide different things, and all without making a new request to the server. So for example, like Google Maps, Gmail. Let's just go to Google Maps for a second, maps.google.com. So as we move things around the screen, you'll see like at the bottom and right edges of the page, new images get loaded, right? New images get loaded. This is not something where, like, I don't know if you guys are old enough to have used the old MapQuest, but it used to be in MapQuest you would have like a tiny little portion of a map on screen, and then you'd have like arrows for directions you could go, like top right, south, east, northwest, and you'd click that button and you'd wait. The page, the browser would request a new page from the server, and then the server would give you a new portion of the map, right? So it involved this page fetch cycle. But this does not. Like every time I move, the browser loads these new images. They haven't been loaded until I move. but then some JavaScript code runs here to load these new images. Another example, Twitter. So if I go to Twitter, I don't think I've signed in here yet. Sure. So if I go to Twitter here, you'll notice that like some stuff loaded here, and then some stuff loaded over here, and then some stuff loaded over here, and they loaded kind of sequentially. Like they didn't load all at once. And if I sit on this page long enough, just like with Facebook, if I sit on this page long enough, it'll give me a notification that there's something new. There's new data. New data that didn't exist before. Somebody just made a new tweet that that I subscribed to, and the browser is notifying me that this new information exists. Well, how does it know that new information exists? Another example is Gmail. So you go to Gmail and you hit compose, and you type an email and hit submit. When you click compose, it doesn't make a new page fetch to the server and bring you a composed screen. When you hit submit, it doesn't send the data to the server and wait for a new page to be shown. It sends it, it closes the little div or whatever that the compose area, and allows you to just navigate around your inbox. None of this involves the traditional page fetch cycle. So what we're going to be learning today, it's called ajax. It involves, it's called asynchronous communication. Basically what it is a technique for loading little pieces of information without making a full new page fetch to the server. We're loading tiny little pieces of information behind the scenes using JavaScript, and then once the data has been loaded, we're going to inject it into the page. Or if we need to send data to the server, we're going to initiate an AJAX request to submit some data to the server, and then the server has the information. We don't need to like submit a form. We're going to make a separate request, just like we were a little mini browser making a form submission. We're going to submit that behind the scenes to the server. And this has become an integral component of powerful applications on the web. It's not a programming language. We're going to be using JavaScript to do AJAX. AJAX is a technique, a procedure. So it's not like a thing. It's not an object. It downloads data or submits data to the server in the background. And basically what it does is it allows you to update the page or perform some kind of communication without making the user wait. So this is more of the asynchronous communication pattern. We view a page, we click something, maybe we hit send on our Gmail message. That message gets communicated to the server behind the scenes, and in the meanwhile, I'm free to just do something else. I can go start composing another message. And when I hit send there, then that will get communicated and it'll be sent to the server separately. So all of these requests can happen simultaneously. They happen separately. And the core, the way that we do this, the core of AJAX is called the XML HTTP request object. It's really, really oddly named, but at the time that it was created, so browser makers decided that this would be a cool thing to be able to do, to be able to just like load specifically XML sort of behind the scenes, just make a separate request for some XML code, and maybe that XML code could be used on the page somehow. It's since been expanded in use to not just XML, but also like JSON and just plain text, and also like regular HTML to be injected into the page. But at the time that this object was created, they were like, oh, well, we'll just use it for XML. Yeah. Well, XML is a language. Oh, yeah. HTTP is, yeah. I don't know why that is. Yeah. HTTP also should be capitalized, I suppose. Anyhow, so this is supported. Actually, this was supported pretty far back, all the way back to. Actually, I thought that IE 5 and 6 supported this. This has been supported for a really long time. It's been supported for a lot longer than it's been used, and it sort of sat dormant for a while in these browsers before people actually realized that they could use it. Um, and then all of a sudden it dawned on people, like it started to become a really popular thing. Like, wow, we can use this, and people were like, what can we do with this? This would be really cool, and they started to use it, and eventually it became a really important integral part of the web. Okay, so a typical AJAX request involves an event handler being occurred. So like I click on something, I click the send button in Gmail. That's an event handler. That's an event. In our event handler, our submit event handler, we create a new XML HTTP request object. That XML HTTP request object, I'll just shorten this to XHR from now on. That's a typical abbreviation for it. The XHR object makes a request to the server. It submits data. It asks for information. Basically, it creates a request just as if we had opened a new tab and typed a particular URL into the browser. It makes that request, fetches the data, and then once that data has come back from the server, because there's a little bit of lag in between when you make the request and when the server responds. Typically, it's short, 20, 30 milliseconds. But it could be pretty long. Maybe the server's kind of bogged down and it's taking a while to respond. It might take, a second or two to respond. So the XHR object requests the page from the server. The server processes and retrieves the appropriate data, sends it back, and then the XHR object fires an event that you can respond to when the data comes back. So you sort of in advance, you set up, you say, when the data comes back, run this function and give the data to this function. So this is often called a callback function. So the XHR calls your callback function and gives it the data, and your callback function will do something with the data. It'll process the data. It'll maybe inject it into the page. It'll iterate over maybe objects that are given to you by the server or stuff like that. So we can use XHR objects in many different ways. We can use them synchronized if we want to. Synchronized means that, we'll see that in a sec. Synchronized means that basically it's going to freeze the browser until the request comes back, which is not something that we typically want. Sometimes we do, but most of the time we want asynchronous. Asynchronous means that the XHR request will happen sort of in the background, parallel with anything else that we're doing. So we can continue to interact with the page in different ways. Once I click send on my Gmail message, the XHR object will start communicating with the server, and in the meanwhile, I can click on my other inbox or a different folder or whatever. We can also use it in conjunction with, conjunction with plain text or HTML, but we can also use it in conjunction with, for example, JSON and XML. Ajax, by the way, stands for asynchronous JavaScript with XML, asynchronous JavaScript and XML, which nowadays might be sort of a misnomer because we use it with JSON and with text and whatever, and we might use it synchronously as well, but we just call it Ajax. Okay, the XML HTTP request object has these methods. So we first begin by opening a connection with a particular URL using a particular method. So the method might be get or post. And we can set this connection to be either synchronous or asynchronous. Typically, we'll just set it to be asynchronous. So we open a connection with this particular URL. We send the request. So this actually sends the request to the server. Sends a request to the server at this URL, and then once the data has come back, it needs to be able to call a function that we specify. The way that we specify that is we use. Okay, we'll talk about that in a sec. Once the data comes back, we can get the data in a couple different forms. Our callback function will be passed an object which contains these properties. Response text, response XML are the most frequently used. So if the server gives us XML data back, then we're going to be using response XML. For the most part, at least right now, we're going to be using response text. This, like if we make an XHR request for like an HTML page, for example, maybe it's just a flat .html file, maybe it's a PHP script that outputs HTML, but regardless, what we're going to be getting is HTML code. Then the response text will contain that HTML code, like as if we opened it up in our our text editor. If we open that source code up in our text editor, so that's what'll be in there. Synchronized requests, again, they lock up the screen. They prevent anything else from happening while the request is outstanding. And once the server responds, which could be a long time, then finally things will unclog and you'll be able to do stuff on screen. The way we do a synchronized request is we pass false for this third parameter to open. So if you forget to pass this third parameter, if you don't explicitly set it to true, then your request by default will be synchronous, and you don't want that. So you should always make sure to pass true for this third parameter here. So we create this new XML HTTP request object. We open a new request to a particular URL. We're going to want to pass true here, and then we send the request, and then the XHR object will call our callback, which we haven't specified yet. Again, the whole browser locks up. We want to do an asynchronous request. In order to do an asynchronous request, what we need to do is in advance, we need to specify a callback function so that when the data is ready, when the data comes back from the server, our callback function will be called and given that data. So XHR events. We can attach events to the XHR object just like we can with any other DOM object. And these event handlers will be called in particular events. The ones that we're going to be most concerned about are load and error. So error will be called when the request fails for whatever reason. We'll look into reasons why it might fail in a bit. Load is the one that we really want. That's the one that once the data has been loaded, once the request has come back from the server, we're going to call this event handler. So, for example, we create a new XHR object. We say that object.onload equals our callback function. Then we open the request and we specify true, and we send the request, and then sometime later, however long it takes for the request to be sent and the server to respond, then the browser, the XHR object, recognizes that we've gotten the data back. It will call this onload function. So this is our callback function, and we're going to do something with response text. So this is our callback function, and this is how we're going to be using it. So our example for today is going to be this. So I have this. Oops. Oh, I think I forgot the. Where's the HTML file? Okay, I need to go download the HTML file real quick. Grab this from last quarter. Quotes.html. There we go. Quotes.html. So this is going to be a quote of the day. We're going to fetch quotes from a PHP script. So we have a PHP script. Our PHP script here will, and I need to rename this. Just let me do that. Excellent. So what this will do is this will give us a random quote. So every time we refresh the page, it's going to give us a random quote. and we can look at the source code for this. So it will fetch a file called quotes.txt. That's this file here. And this file has a bunch of quotes, each separated by 2 new lines. So there's a line in between. We're going to split it on 2 new lines, and we're going to get a particular number of random number of quotes. By default, we're going to get 1 quote, but we might, if we pass a second parameter, a count parameter, then we might get multiple quotes. But by default, we're just going to get 1. And what we want to do is when we click the fetch new quotes button, we want to make an ajax request to the PHP script, and that ajax request will fetch this new quote, and we want to inject that new quote into the page. So let's so we're looking for a quotes.js file, so we will create that quotes.js file, quotes.js. Let's wrap this in a module, function pren, blah, blah, blah. Call it, okay, so we're in a module now. We'll use strict. And, okay, so what we're going to do is when the fetch button is clicked, we want to, let's just start by just making a request to the server. So we'll add an event handler. So let's see. So we're going to want to say window dot add event listener. We're going to listen for the load event, and when that happens, we will attach a click handler to window. Let's see. Document dot get element by ID fetch dot add event listener, click, fetch, new quote. So we'll run a function called fetch new quote. Function fetch new quote. So this is the function that will initiate an ajax request to the server. We're going to initiate a request to quotes.php. So in order to create a request, we're going to follow this procedure here. So asynchronous request, create a new XHR object, set a callback function, open the request, and send it. Oftentimes we just call this object the ajax object, but we can, oftentimes it's also called XHR just because, you know, it's an XML HTTP request object. I'll call it XHR just because that's kind of what I prefer. So we're going to initiate a GET request to quotes.php. So that's the program that we want to make a request to. That's the URL that we want to make a request to. We want to make sure that it is asynchronous by passing this third parameter true, and then we're going to send the request. In advance, we've set up this callback function, so we're going to have to specify the name of this function. We'll say got new quote. I like to say got new quote. I like to, when I name my my Ajax functions, when I name my like fetcher function, or like, you know, the function that actually makes the request, you know, I like to call it like, you know, get new quote or whatever, like, you know, to indicate that this is making the request, and then once I get the data back, then I have the data, so I got the new quote. So here, let's just say alert, and we can make use of this dot response text. This, because what we're doing is we're attaching this callback function to this XHR object, this, is embedded inside this XHR object. So this refers to the XHR object itself. This dot response text indicates is the text of the data that came back from the server. So this dot response text. Refresh that. Fetch. Okay, so it gives us one quote. Fetch again, gives us another quote. Fetch again, gives us another quote. Okay. I want to inject this quote into the page. I want to inject this data into, let's see, PID equals quote. So I want to inject that into quote. All I got to do then, document.get element by ID quote dot what? Inner HTML equals this dot response text. Bam. Let's add the parameter to this request here. So we can optionally, if we pass a second parameter, I think it was count equals 5. It'll give us 5 quotes instead of just 1. Okay, so if we enter a number here, we should pass that number that we enter to the server. In order to do that, let's get that piece of data. We can say var count equals document.get element by ID count dot what? Value, right? So we can't just say this. I kept saying that before and messing things up. Dot value is the value inside of that we entered into the box. So that's the count, and we want to pass that count as a parameter to quotes.php. So how should we do that? How do we go about passing a query string parameter to it? Keep in mind that this is just a URL. What's that? .send. So if we want to create a post request, we are going to have to use send to send data. We'll see that in a sec. But if we're just making a GET request, if we want to pass it in the query string, we can modify this. This is just a URL. We can modify this to add a query string. So we can say count equals count. We concatenate that to the URL. Okay, so refresh, fetch new quotes. Now we have 5 new quotes. This isn't formatted particularly well. All of these quotes are just on separate lines or whatever. Let's take a look at the exact data that was given to us. And in order to do that, we're going to open up Firebug. And this is probably one of the most powerful uses of Firebug that there is. In addition to actual debugging and inspecting CSS information and figuring out what CSS is being applied to things, this is another of the most powerful uses of Firebug. So there was a request. So when I refresh this, it'll show me. So if I go over to the Net tab, this will show me a list of all the files that have been loaded so far since I refreshed the page. So first it fetched quotes.html. That's that's this file that I requested. This file in turn loaded quotes.css and quotes.js. So there are requests there for that. Now when I click fetch new quotes, a new request shows up. This is the XML HTTP request. This is a separate request that was made to the server behind the scenes. And I can inspect any one of these. I can open this up and I can see what headers were sent. We'll talk about headers probably on Monday. I can look at any parameters that were sent. So we had a parameter of count that was whose value was 5. That was sent to the server. And then we can also look at the response. This is the exact text that it sent in response. And so we can see that this is exactly how it's formatted and so on. Maybe in order to make this show up properly, why don't we go ahead and do like, well, why don't we go ahead and modify the PHP code? Let's do print. So when we print this quote, this random quote, instead of separating them just with new lines, let's actually like, and this is kind of bad style here. I'm actually printing HTML, but actually this entire thing here, none of it is actual HTML code, so I think this is kind of okay. We just have a little snippet of HTML code there. So when we make this request again, so we don't even have to refresh this JavaScript page here. When we make a new request, we can take a look at the new response from the PHP code, and now everything is surrounded with p tags. And now, when stuff is injected into the page, it's separated, right? If we look at the actual like structure of this HTML document now, inside of PID equals quote, we have separate paragraphs. So we injected HTML directly into the inner HTML of this quote thing. And now we've injected new HTML into the page that was fetched by the server, fetched from the server. Okay, the last thing I want to do really quickly is I want to illustrate the time gap between when the request is made and when the server responds. So what I want to do is I'm going to sort of make this quotes.php take an artificially long time. I'm going to make it sleep for like 2 seconds. Like there's a special function in PHP that allows me to just wait for a little while. And when if I wait for 2 seconds before I respond, then it becomes a little bit more obvious from the client side that the server is taking a while to respond. And what I want to do is, while the request is outstanding, I want to do some more psychedelic stuff. And I'll just do that really, really quickly. So while the request is outstanding, I'm going to let's see, set interval change color every 20 milliseconds. Change function change color. Document body background color equals RGB. Let's see, plus R plus comma plus G plus comma plus B plus that. Okay, and we'll say var R equals math dot floor math dot random 250 times 255 GB. Okay, we're going to change color, and then when we got the new quote, what we're going to do is we're going to timer equals blah blah blah. We'll have a timer up here. Var timer equals null. We'll clear the timer down here. Clear timeout. Clear interval timer.
Or you would see a quote didn't change color.
Bottom right.
After RGB.
Thank you. Thank you. Okay, now when we refresh the page, the server is going to take a little while to respond, and our interval timer isn't working. Set interval change color every 20 milliseconds. Document body to background color. Style dot background color. There we go. So while the server a request is outstanding, we're going to change the colors, and once it responds, then we stop. Okay. Sorry for taking a little bit longer. I'll see you guys on Monday. Oh, there's also an extra session today. If you'd like to learn about jQuery, the jQuery JavaScript library, which is an incredibly powerful and useful JavaScript library, then feel free to stay.
was wondering if I can make an appointment with you possibly today.
Sure, yeah. Like after the extra session?
Well, I've got a 3:30,
Okay.
so I don't know if
Um,
I'd be possible. I mean, depending on when you're done, I might be able to stay for a couple like extra minutes. Because let's see, because you said you'd
So
be
you have
done
a
around
3:30?
3:15.
yeah, I'd be done around 3:15.
Like while it's playing.
Oh, yeah. Okay, yeah, so I can...
2:30.
While it's playing, everything should be disabled except for the
Okay, excellent. My appointment is at 3:30. So it's to end at 3:15.
Okay, yeah, so if you end at 3:15, then we can just
Because I've got an
for a
appointment.
while.
Yeah.
Yeah.
Okay, sure. Let's see. The interpreter might not be available. So
That's
I
fine.
have to
We
leave at
can just
3:15.
type.
Great. Cool. Thanks. Appreciate it.
Are you going to screencast the extra session?
Yeah.
Okay. So I have a picture, so I should go to
That's
that.
fine. Yeah. Go to your midterm.
Oh,
yeah, we'll screencast it.
Yeah, I wanted to see this one.
Okay.
Is it good way to think about it? Sort of like, I feel like ajax is sort of like threading.
Yeah, sort of.
Okay.
Yeah. You're sort of spinning off a separate thread that's going to make a request, and then when it's done,
Get like periodic. Like if you actually have something where it's like fetching a ton of data, is it possible to send like small packets of data, sort of like for some, like how far it's done?
you mean like split the request up into separate packets?
Sort of. Yeah. Well, I'm thinking of like progress bars.
I suppose like you could artificially sort of split it up as long as the server program knows how to receive it in separate chunks. You could split up the data into separate chunks. First, the data, like, there's no way in the browser of splitting up, like, if you're submitting a file, if you have, like, an input type equals file,
Yeah.
and you, like, choose a file, there's no way using the browser to split that up into separate binary chunks
Yeah.
and submit each binary chunk separately. That's not possible. Okay.
It is 2:30 appointment.
Okay.
Let the interpreters go.
Okay.
But they will be coming back.
Okay, we'll be coming back after the
Yeah.
extra session.
Yeah.
Excellent. Okay. Yeah, so like submitting, like, the only way you could do it is if like you actually like entered text into a box, you know, which like if you enter a lot of text in a box, you know, chances are you don't really need progress on it. I think there might be other ways that you can do a progress bar. I feel like some libraries might be able to like loop into some like specific features of the browser that allow you to receive status updates, but I'm not sure. Are you just gonna watch the screencast?
Yeah.
Okay, that's fine. That's fine. Mm-hmm.